Hello, and welcome to Advanced Mathematics 1, Unit 3, Part 1, Points, Lines, Planes, Segments, and Arrays, our first introduction into geometry. By the end of today's lesson, you'll be able to do the following. Name points, lines, and planes, name segments and arrays, and use the segment addition postulate. So let's just jump in. Our main concepts are as follows. A postulate is a rule that is accepted without proof. So in other words, these are basic truths in math. There is no way of saying proving that they're true. They just are true because they're true. All right, our first postulate is called the segment addition postulate, and it says two things. It says if B is between A and C, then AB plus BC is equal to AC. And it also says the reverse. If AB plus BC equals AC, then B is between A and C. Really, the first one is the one that we use practically, but both are part of the postulate. The rest is all definitions, so let's jump right in. A point is an object that has no dimension. This diagram of a point would be called point A. A line is a one-dimensional object that extends without end. Through any 2 points there exists exactly one line, so you can pick any 2 points and there will be one line that goes through those points. This line would be written as follows. It would be written as AB with the little line arrow above it. That is how you designate a line. A plane is a 2-dimensional object. It also extends without end. Through any 3 points not on the same line, there is exactly one plane. So this has three points on here, and I could name it plane ACB. I could also name it plane M because that's not a point. So that's 2 ways I could name this plane. Moving on. Collinear points are just points that are on the same line, so these 3 little blue points would all be collinear. Coplanar points would be points on the same plane, so A, C, and B were all on the same plane. A line segment is a portion of a line that contains 2 endpoints and everything in between them. We designate a line segment by its letters and just a little line above it. We don't put dots on the ends or anything like that, just a little line with no arrows or anything like that. That's how you designate a line segment. Array is a portion of a line that contains one endpoint and everything in one direction from that endpoint. So in this case, from A onward. We name it again with 2 points with an arrow over top of those 2 points. And last but certainly not least, we have opposite rays, which are 2 rays on the same line with the same endpoint that head in different directions. So in this case, our 2 opposite rays would be CB and CA because they both have the same endpoint C, but they go in different directions. And those are all our lovely definitions for today. So let's move on. All right, in our first example, we're given this diagram up here, and we're asked a bunch of questions about it. So let's just go into those questions. First of all, it's asking us to name another name for plane M. So a plane can be named by 3 non-collinear points. So I can't use X, Y, and Z because they're all on the same line, but I would start by writing the word plane. And then I'm going to give 3 letters that are not on that same line. So I could do X and Z. I could also use Y and Z. It would be another possibility. I'm not going to rewrite the word plane. You can write one of those, so you don't need to write both. All right, the second question asks us to name a line in the plane. So the line that is in the plane is the one that's going left to right. There are a few ways to write that line. I can write it as XY because it contains both X and Y. I can write it as YZ because it contains both Y and Z. Could also write it as x and xz, because it contains both x and z. And there's one other way I can write it, and that's this little letter up in the corner that you can barely see up here, and that is line G. Most people are going to prefer the point method, but occasionally you can use the letter method like that. All right, part C says name a line intersecting the plane. That means crossing through the plane. So that would be our vertical line. So there's only two ways of naming that because there's only 2 points on that line. So I can use the 2 points that are on the line, which are PY, the line above, to indicate that, or I can use its letter, which is N. So it would be line N. All right, D says to name 2 segments. So any 2 points, so basically the same pairs of letters that I've already used for everything else. So I could do XY as a segment. I could do YZ as a segment. I could do XZ as a segment. I could also do PY as a segment. Sorry about the sloppy P there. There we go. And those are all the possibilities of segments. So any 2 of those would be your answer in this case. I just named all 4. All right, name a pair of opposite rays. So opposite rays have to be on the same line. So there's only one line that has 3 points on it, and that's our horizontal line. So that's X, Y, Z. So our common point is the point in the middle, which is Y. So my rays would be Y, X, and Y, Z. And that's how I write that. And last but not least, we are supposed to name a point not in the plane. So the only point not in the plane in this diagram is point P. And there we go. That's example 1. All right, in example 2, we're asked to find DF. So this is basically the segment addition postulate. And that postulate says that the entire segment, DF, is equal to the sum of its parts, DE plus EF. So I would just add the 2 parts, which is 23 and 35. So very, very simple. Just do that math real quick. 23, 35, add together 58. And there we go. All right. This next one, however, example 3, says to find QR. Again, I'm just going to write the postulate. You do not have to do this, but it's just to show you what's going on. So the entire segment, PR, is equal to PQ plus QR. Now, in this, I'm asked to find QR. So I'm going to solve this equation for QR by subtracting PQ. So QR is equal to PR minus PQ. So this is all letters. We're not solving for anything. We're just putting the letters in. So PR in this diagram is 13y minus 25, or plus 25, sorry. And then we want to subtract PQ. So I'm going to put PQ in parentheses because I'm subtracting it. So PQ is 8y plus 5. So now all I need to do is distribute. So I have 13y plus 25 minus 8y minus 5, distributing that negative through. Now I need to combine like terms. 13 minus 8 is 5y, and then 25 minus 5 is 20. So the length of QR is 5y plus 20. All right, in our last two examples, we are still using our addition postulate. This first one's example 4 is a little bit easier than example 5, so let's jump in. Example 4, we're going to use the addition postulate the normal way. So we're going to set it up as our entire segment, RP, is equal to RQ plus QP. And then we're just going to put in our information from the diagram in there. So RP is x plus 24. RQ is 2x plus 21. And QP is 12. So now all I have to do is combine like terms and solve the equation. So this side just stays the same. Over here I have 2x plus 33. I'm going to subtract x from both sides. I have 24 equals x plus 33. Subtract 33 from both sides. Uh, 24 minus 33 is negative 9. Final answer. All right, example 5. This one has four segments. We have J to I to J, H to G. All of those add together to make G to J. But that if we try and set it up that way, it's not really going to work out. So we want to look at our picture. And we kind of see in the middle here, we have this 13 and the 22. If we look at them, they overlap by this amount right there. That's the overlap, the distance between I and H. So if I set this thing up, if I were to add the 13 and the 22, I would have the whole segment, but it would be too much by that IH. So if I take those two and add them and I subtract the IH back out, I will get the entire segment. So that's how I'm going to set up my equation. So my entire segment is x plus 12. And that's going to be the two numbers added together minus that overlapping portion. And now I have my equation. So I'm going to go ahead and simplify this. I'm going to, go ahead and put those together and then distribute as well. So I have x plus 12 over here. 13 and 22 is 35 minus 2x plus 10. Now I'm going to go ahead and move x's at the same time as combining the terms. So you'll forgive me. I'm going to go ahead and move this 2x over to the other side. Over here I have 3x plus 12 equals, and then we have 35 plus 10 over here is 45. So I'm going to subtract 12 from both sides. And I get 3x equals 33. Divide both sides by 3, and I get x equals 11. So that's my final answer. So when you get these complicated looking problems like this, you just really need to look and see what you can do to find an overlapping part, two parts that might add to the whole thing but are too much by an overlap, and subtract the overlap. Just take your time and really look at the diagram to see how you can set it up. And that's it for this time, and I'll see you next time. Goodbye.